Hello and welcome to another episode of CSEC Math with Sir Kumar. In today's episode, we're going to look at frequency tables with ungroup data and frequency table with group data. We would use raw data and then construct our frequency tables, and then we have some probability and relative frequency questions to answer under each example. So get your pen, books and calculator and let's get into it. So we're going to start with frequency table with ungrouped data. But before we get into the actual frequency table, let's first define what is frequency. So the frequency of an event or observation or score is defined as the number of times an event has occurred. I have 10 numbers here, and let's say these 10 numbers were obtained when we roll a die. So we have 1, 4, 5, 6, 1, 3, 1, 4, 5, 6. Now the frequency of an event is the number of times an event has occurred. So if they ask you, what is the frequency of getting a 1 when you roll the die, then you're going to check how many 1s we have. And we have 1, 2, 3. So the frequency of a 1 is going to be 3, because when we roll the die the 10 times, we got 1 3 times. What about 4? The frequency of getting a 4, we have 1, 2 of them, and then so on. So the frequency is the number of times an event has occurred. Now, a major way of organizing raw data into orders, arrange them in a form of frequency distribution, and a tally chart is the best method of doing this. Now everybody should know what a tally chart is, or how we record data in tally form. But in case you don't know, for tally we have 1, 2, 3, 4 strokes, and then 1 coming across, tying it in a bundle of 5. So every time you see this represents 5. 1, 2, 3, 4 is going to be 4. 1, 2, 3 is going to be 3, 1, 2 is going to be 2, and this is going to be 1. So we're going to use a tally chart in our frequency table to record our ungrouped data. So now let's look at an example of constructing a frequency table with ungrouped data. Let's look at an example of constructing a frequency table with ungrouped data. So there are 50 participants in a shooting competition. The score of each participant is listed below. Well, you have the scores here. So if you check 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 by 5 is going to give me 50 numbers. These numbers should be in line, but my hand carry a little slope, so I didn't get them in line. So it's going to be 10 numbers in each row. So this is a list of raw data. So we have to use this list of raw data, and we have to construct our frequency table. Now to construct the frequency table, we have 3 headings. So the first one will be score. The middle part is going to be tally, and then we have frequency. Good. So for the score part, we have to look at the raw data. The smallest number, the smallest score we're working with is 0. And the largest number we have here is 7. So that means my score is going to go from 0 to 7. So on the score, we're going to put 0, 1, 2, 3, 4, 5, 6, 7. So let me just do some lines across to make this a little bit more clear. Alright, so there you have the frequency table. Now what we have to do is we have to go through each individual score and place them in the correct row. So we're going to work in columns. So we have 6, 1, 4, 5, 6, 1, 4, 3, 0. So where 6 is, I have to put a stroke, and I'm going to cancel this out. 1, 4, 3, and 0. So I'm done with this row. Sorry, this column. Then I have 3, 1, 5, 0, 4. 3, 1, 5, 0, 4. So this row is also finished. 7, 4, 6, 1, 3. 7, 4, 6, 1, 3. This one is finished. 0, 1, 4, 1, 5. 0, 1, 4, 1. So you see we already have 4 here, and then you have another one, so we're going to close this off. So that's 0, 1, 4, 1, 5. So 0, 1, 4, 1, 5. So here you have your first 5, right? Let's go to the next column. 2, 5, 3, 1, 7. 2, 5, 3, 1, 7. Then 4, 3, 1, 2, 5. 4, 3, 1, 2, 5. Cancel this out. 6, 3, 2, 1, 0. 6, 3, 2, 1, 0. 7, 6, 3, 1, 4. 7, 6, 3, 1, 4. 1, 3, 4, 7, 6. 1, 3, 4, 7, 6. 3, 0, 1, 4, 1. 3, 0, 1, 4, 1. And that completes all our raw scores. Now what we're going to do is we're going to take our tally, and then we're going to write them under our frequency. So for 0 we have 5. For 1 we have 5, 10, 11, 12. 2 we have 1, 2, 3. 3 we have 5, 6, 7, 8, 9. 4 we have 5, 6, 7, 8. 5 we have 1, 2, 3, 4. 6 we have 5. And 7 we have 1, 2, 3, 4. So from our raw scores that we had, we went through each individual score. We constructed our frequency table with our smallest score going to the largest score, and then we went through each individual number and we placed them into our frequency table. So what you have here is the frequency table. The second part of this question is to calculate the relative frequency of the score 5. Now before we calculate the relative frequency, we have the formula here to calculate relative frequency. So the relative frequency of an event, you could get your answer as a fraction, or you could do your answer as a percentage. As a fraction, relative frequency is equal to the frequency of the event divided by the total frequency. And to calculate the relative frequency as a percentage, it's going to be the frequency of the event divided by the total frequency multiplied by 100, because percentage is out of 100. Now, to calculate the relative frequency of the score 5, the first thing we have to do is identify our score 5. So here is our score 5. And the frequency for 5 is 4. So the frequency in this, the frequency of the event here, is going to be 4. So here we have the frequency of the score 5 equals 4. The other part of the formula asks for the total frequency. Now to find our total frequency, we have to sum our frequency column. And if you could recall from the question, there were 50 numbers. And if you add 5 plus 12 plus 3 plus 9 plus 8 plus 4 plus 5 plus 4, we're going to get 50 here. So the total frequency is 50, and the frequency of the score 5 is 4. So let's use our the two formula and calculate the relative frequency. So the first one we're going to look at is as a fraction. So as a fraction, we have RF is equals to the frequency of the event, which we said was 4, divided by the total frequency, which we calculate here to be 50. So 4 divided by 50 is going to give me 0.08. So the relative frequency as a fraction for the score 5 is 0.08. And as a percentage, we have RF is equals to the frequency of the event, which is 4, divided by 50, the total frequency, multiplied by 100. We put this over 1, 50 ones, 50 twos. So as a percentage, it's going to be 8%. So the relative frequency, when we say we're calculating relative frequency is like experimental probability, right? So you have here the RF as a fraction is 0.08, and as a percentage it's 8%. The third part of the question is to calculate the probability that if a score is chosen at random, that it is greater than 4. Now, we're looking at these words, greater than 4. So greater than 4 does not include 4, right? So that's going to be 5, 6, and 7. The scores 5, 6, and 7 is greater than 4. So to find the probability, P is equal to the frequency of the event divided by the total frequency. But in this case, we don't have one event, we have 3 of them. So the frequency of scores greater than 4 is going to equal to, the frequency here is 4, the frequency for 6 is 5, and the frequency for 7 is 4. So we have to add these 3 frequencies, and that's going to be 4 plus 5 plus 4, and that's going to give me 13. And our total frequency is equals to 50. So the probability, P, is equals to the frequency of the event, which would be scores greater than 4, that is going to be 13 divided by the total frequency, which is 50. And 13 divided by 50 is going to give me 0.26. So the probability that if a score is chosen at random is greater than 4, it's going to be 0.26. Remember, you have 50 scores that we're working with. So if you select a random score and you want that score to be greater than 4, then the chances of you selecting a score that's greater than 4 is 0.26. Note that probability goes from 0 to 1. 0 means that it's an impossible event, and 1 meaning that it's a possible event. It cannot go over 1. So when you calculate probability, if you get something that's more than 1, then then likely you're incorrect. So it falls between 0 and 1. We're looking at frequency table with group data. In our first example, we looked at ungroup data. Now, if you notice here, we have 100 numbers. Now, if we were to use ungroup data, then our smallest score here, our smallest mass would be 35, and the highest one would have been 84. So under mass, we would have had to list from 35 to 84, making this table very large. So instead of doing all of that, we're going to group our data. And that's why when you group data, you have something called class or intervals. And you use the intervals and then you place your raw scores into the given intervals. Now, if you look here, the question says draw up a tally chart for the classes 35 to 39, 40 to 44, 45 to 49, 50 to 54, 55 to 59, 60 to 64, 65 to 69, 70 to 74, 75 to 79, and 80 to 84. So they have already given you the classes that you have to use. So using these classes, we're going to set up our table. And we're dealing with masses. So in our first column, we have the mass, and that's in kg, and then you state the classes that they have given you. So you go 35, 39, and so on until you're at 80 to 84. Our middle column again is tally, and at the end we have frequency. Now, what we have to do now is we have to go through each number or each mass, and then we have to place them into this table. So let's start. So I'm going in columns, 35, 41, 47. So 35, 41, 47, 53, 64, 71, 53, 64, 71. So what you should notice is that we have the individual numbers. So 35 is going to fall between the range 35 to 39. 41 is between 40 to 44. 47 is between 45 to 49. 53 is between 50 to 54, and that's how you place them, right? So let's continue. 84, 75, 63. 84, 75, 63, 52, and that's our first column. 44, 59, 52, 44, 59, 52, 63, 72, 81, 63, 72, 81, 54, 63, 65, 54, 63, 65, and 70. Good, we're done with the second column. 81, 37, 42, 81, 37, 42, 38, 39, 45, 38, 39, 45, 63, 65, 71, 81, 63, 65, 71, 81. Next column, 82, 68, 67, 82, 68, 67, 75, 78, 69, 75, 78, 69, 64, 58, 64, 58, 57, and 49. 64, 58, 57, 49. 37, 38, 47, 37, 38, 47, 45, 63, 64, 45, 63, 64, 69, 68, 69, 68, 73, 75, 73, 75. Next set, 44, 49, 51, 44, 49, 51, 58, 67, 68, 58, 67, 68, 42, 58, 59, 42, 58, 59, 60. 38, 35, 37, 38, 35, 37, 41, 48, 54, 41, 48, 54, 58, 67, 68, 58, 67, 68, and 75. Good. 84, 83, 64, 84, 83, 64, 79, 68, 61, 79, 68, 61, 64, 74, 71, 64, 74, 71, 64. Last two columns, 55, 58, 59, 55, 58, 59, 45, 47, 49, 45, 47, 49, 37, 39, 43, 37, 39, 43, 58. Our last column, 61, 83, 54, 61, 83, 54, 39, 75, 42, 39, 75, 42, 57, 81, 62, 57, 81, 62, and then you have 70. And there you have it. We've just inputted 100 numbers on our frequency table. Now that we've entered our numbers into the frequency table, we're now going to write our frequencies using the tally. So here we have 5, 10, and 2, that's going to give me 12. 5 and 3, that's going to give me 8. 5 and 5, that's going to give me 10. 5 and 2, that's going to give me 7. 5, 10, and 2, that's going to give me 12. 5, 10, 15. 5, 10, 11, 12. 5, 6, 7, 8. 5, 6, 7, and 5, 6, 7, 8, 9. Now using our frequency table, we have one other part to this question, and we're going to use our frequency table to solve that. Remember that you need to be very careful when you're going through these numbers and placing them into the relevant classes, because sometimes it gets a bit confusing given that it's a whole lot of numbers. So this one carry 100, you would find some questions with 120 numbers, 130 numbers, and so forth. So you just have to take your time, go through the numbers, and then enter them onto your frequency table. The second part of the question is to calculate the probability that the mass of a student selected at random is 1, less than 60 kg, and 2, at least 60 kg. Now, the first part, we're going to look at the first part here, which is less than 60 kg. When we say less than 60 kg, that means we're working from 59 going down, right? So if you look at our classes, this is 60. So we have to start with this class to 35, 39. So we're looking at the frequencies of the class 55, 59, 50, 54, 45, 49, 40, 44, and 35, 39. So the frequencies of those classes less than 60 kg would be 12, which is, we're working with these numbers, 12 plus 7 plus 10 plus 8 plus 12. And when we sum this up, we're going to get 49. Now the total frequency would be the sum of this entire column. So 12 plus 8 plus 10 plus 7 plus 12 plus 15 plus 12 plus 8 plus 7 plus 9 is going to give me 100, because we were working with 100 numbers for the question. So to find the probability that a mass that a student selected at random is less than 60 kg, we say P is equal to the frequency of the event, which we found to be 49, divided by the total frequencies, which is 100. 49 divided by 100 is going to give me 0.49. So 0.49 is the probability that if you select a student at random, their mass is going to be less than 60 kg. The second part of part B asks to calculate the probability that the mass of a student selected at random is at least 60 kg. Now, at least 60 kg means that the least a student could weigh is 60. That means we have to include the class with 60. So if 60 is the least, therefore we have to go from 60 to the class that's 80 to 84. So we're working with 60, 64, 65, 69, 70, 74, 75, 79, and 80, 84. And those frequencies are 15, 12, 8, 7, and 9. So at least 60 kg, this would be the frequency of the event. We have to add our frequencies, and that's going to be 15 plus 12 plus 8 plus 7 plus 9, and when we sum them, we're going to get 51. Our total frequency is equals to 100. So the probability that a student selected at random is at least 60 kg is going to be 51 divided by 100. And when we divide them, the probability is going to be 0.51. So the probability of selecting a student out of the 100 to be at least 60 kg would be 0.51. To wrap up today's lesson, we've looked at frequency table with on-group data and frequency table with group data. Remember, when we're looking at on-group data, we have a smaller set of raw scores or raw numbers to deal with. And when we're looking at group data, they usually give us the classes that we have to use to place the raw data given. In both, you have to calculate, or you've learned to calculate, the probability and the relative frequency when they give you questions.